Hello, I'm Ransi Somaratne, Chief Medical Officer at Epirium Bio. We're a privately held biotechnology company in San Diego developing new medications to address the profound bioenergetic deficits and muscle degeneration seen in neuromuscular disorders, regardless of their genetic cause. We're grateful to Parent Project Muscular Dystrophy for this opportunity to discuss our work and progress that I'll share with you over the next few minutes. Epirium is committed to the treatment of patients with Becker and Duchenne muscular dystrophy by developing a differentiated therapeutic approach that may address underlying drivers of disease. Our lead candidate, EPM-01, couples the stimulation of mitochondrial biogenesis meant to restore tissue bioenergetics with the upregulation of key proteins, potentially leading to improved muscle structure and function. As we see on this slide, mutations in the dystrophin gene set off a number of harmful processes in muscles, and those lead in turn to a series of events ultimately resulting in fibrosis or scar formation. Starting with contraction-induced damage to the muscle membrane and the resultant abnormal calcium signaling, these changes can lead to inflammation, damage to mitochondria, damage from oxidation injury, and formation of scar tissue. Some of these drivers can occur independently after membrane damage or secondarily as a result of one of the other events seen on this slide. Drivers can also contribute to worsening of other driving factors shown here. The replacement of healthy muscle tissue with fibrosis only worsens the amount of contraction-induced damage, resulting in an ongoing cycle of damage, leading to scarring, which leads to more damage, and so on. Mitochondria play a double role here because not only do they provide the energy necessary for muscle function and repair, but also when they're damaged, they actually contribute to disease progression by generating free radicals and triggering an inflammatory response. Therefore, improving mitochondrial health appears to be an important intervention in preventing worsening of disease. We believe that restoring energy balance through mitochondrial biogenesis is integral to promoting muscle repair and regeneration. EPM-01 is structurally highly similar to an endogenous hormone that itself is closely associated with stimulation of mitochondrial biogenesis and regulation of muscle growth. This is an important characteristic of the drug, and we believe gives it the unique ability to couple energy production with muscle regeneration, two biological processes that are very important to patients with dystrophinopathies. Studies of EPM-01 in non-clinical models suggest that it favorably affects important regulators of both mitochondrial biogenesis as well as muscle growth and regeneration, and has shown improvements in exercise capacity in animal models. As I will show you, Epirium Bio has also conducted a small study of EPM-01 in patients with Duchenne muscular dystrophy, which supports these observations by showing improvements in biomarkers associated with key steps I showed you earlier, including muscle growth and regeneration, inflammation, and oxidation. Next, I will highlight data we obtained in relevant animal models of muscle atrophy with an earlier, less potent version of EPM-01 called EPM-03. Looking at these mouse models with disease factors that actually overlap with Duchenne and Becker muscular dystrophy, we found that the Epirium compound improved key drivers in the disease pathway that I showed you earlier, including inflammation, oxidative injury, fibrosis, muscle regeneration, and mitochondrial biogenesis. In these animal models, we also observed improvements in muscle strength, including in an MDX mouse model. Encouraged by the promising data you just saw with the less potent version of the drug, we decided to further optimize this drug class and continue development of a potential treatment for patients with muscle disorders, namely with EPM-01. Taking EPM-01 into humans, we conducted a small study in non-ambulatory patients with Duchenne muscular dystrophy and noted improvements in key disease drivers as well as in cardiac function, alongside encouraging data on exercise performance. An earlier study you see on the right-hand side of this table with the less potent drug in patients with Becker muscular dystrophy was encouraging and provided additional information on mitochondrial biogenesis, dystrophin, and plasma BNP. Taken together with the non-clinical data, we believe that EPM-01 has the potential to lead to clinical and functional benefits in patients with dystrophinopathies. This takes us back to where we began the presentation and the key driving factors of disease progression in dystrophinopathies. Epirium's experience with its older and the newer, more potent compound called EPM-01 suggests that coupling mitochondrial bioenergetic improvement with meaningful shifts in muscle growth and regeneration have the potential to offset and potentially stop progression of muscle degeneration and fibrosis in these patients, ultimately enabling functional benefits. To summarize, Epirium's approach harnesses key physiologic processes that are associated with energy and muscle regeneration. Our drugs have been studied in over 110 human study participants, including children, across multiple disease states. The non-clinical models successfully translated into early studies in patients with Becker and Duchenne muscular dystrophies, and we are excited now to be moving forward based on what we've learned so far. Riparian Bio recently obtained FDA orphan drug designation for EPM-01 in Becker and Duchenne muscular dystrophy, and we are now in the process of starting our first EPM-01 trial in Becker muscular dystrophy patients to assess safety and tolerability of 3 doses of the drug, along with secondary assessments of cardiac function, muscular function, dystrophin, along with other biomarkers in a phase 1 study. We're also driving towards EPM-01 trials in Duchenne muscular dystrophy. Thank you very much for your attention and your interest. Thank you once more to Parent Project Muscular Dystrophy for this opportunity. And thank you to our scientific collaborators, clinical investigators, clinical research teams, and most of all, patients and families for their time and support. If you would like to learn more about Epirium Bio, please visit our website at www.epirium.com. Thank you.